Welcome to The Scoop, NANP's monthly educational webinar series. I am your host, Andrea Granson, Education Program Specialist for the NANP. These webinars are recorded and everyone who registered will receive a link to the recording. NANP members can earn 1 continuing education credit for participating in Scoop webinars by taking the corresponding quiz, which can be found in the membership area of the NANP website. Today's webinar will conclude with a Q&A session, so please feel free to type in your questions as we go along so we can get to as many as possible at the end of the presentation. Okay, so let's get started. Today we have Anne Pemberton, and Anne's passion for nutritional approaches was fueled following the birth of a son later diagnosed with autism. Being told to go away and enjoy the child because he would always be a 3-year-old little boy was not what she wanted to accept. Today, Anne's son is now able to work. He holds his own master's degree in engineering and a responsible role as a software engineer for a multinational company. The launch of genetic testing for the consumer via 23andMe brought a new avenue of exploration. To this end, Anne has undergone further training to offer this to those with complex conditions who may not be achieving the goal they would like. Anne maintains her nutrition qualification while adding this to her psychology, nutrition, and teaching qualifications. She has extensive experience as a combined nurse and nutritional therapist in environmental medicine with Dr. Damien Downing, with whom she recently co-authored the book, The Vitamin Cure for Digestive Disease. Anne produces articles for CAM magazine and is a regular conference speaker. Since 2010, Anne has been the course director for the Master's Nutritional Therapy course based at the Northern College of Acupuncture in New York, where she leads the teaching team and acts as clinical supervisor in the teaching clinic. Welcome, Anne, and thank you for joining us today.
Oh, thank you, Andrea, for that lovely introduction. I'm honoured, absolutely honoured to be here. So I've been asked to talk about nutrigenomics for you all, and I thought if I just give a taster so that you have some take-home key points. It's more of an introduction than anything. I'll talk you through what I'm going to do. So I don't need to introduce myself because Andrea's done such a wonderful job. And as she says, my nutrigenomics interest was sparked back in 2010 when Dr. Ben Lynch became the MTHFR king. And I was very fortunate because my longtime friend Nikki Gratrix was supposed to be his supporting act on the ICAM stage, and she couldn't come back from the US. So she asked me if I would take her place. And that really launched me as a practitioner, so I will always be grateful to Nikki for that. I did Ben Lynch's course in 2010 to 2011, and then I went off and attended his SheCon events in 2016 and 17 in Seattle. I've done some courses with Michael McAvoy, who owns the Metabolic Healing outfit, and Dr. Jess Armine is a personal friend. Dr. Jess is what do we call him? He's a neurotransmitter whiz kid. I've also trained with Peter D'Adamo, and he has the Opus 23 kit, which allows us to put in Ancestry.com and 23andMe data and produce our own reports, and that's very evidence-based, so I like that as well. In 2014 to 17, I had my own company in the UK, well, a joint company with a personal friend. We opened up a company called Gene Snippers, where we taught nutrigenomics to our UK practitioners. I had to finish that in 2017 because I had a near-death experience and had to shut everything down. And but here I am, I'm back. And Andrea told you about the books. Well, these are the 2 books. The Vitamin Cure, which Dr. Downing and I wrote for our patients. So it's more a revision book, really. And the other one is Using Nutrigenomics Within Personalised Nutrition. I'm going to tell you a little bit about the book, and then I'll go into the pathways So this is just in case any of you need a book of this description. I've tried to make this really applicable to practitioners. I've tried to make this as easy as I can, because it's quite a complex area and there's certain aspects of it that we need to be really mindful of. So I'll go through an overview of the book, which is using nutrigenomics within personalised nutrition. I'm going to preamble through the book sections and give you an overview of the case study that's in the book and how that works within the book. I'm going to offer you 2 insightful models that might enhance our understanding of nutrigenomics in a bigger field or bigger picture. And then I'm just going to go through the basic pathways and teach you how to read them if you've never done that before. And then at the end of it, there'll be some key safety messages. So hopefully you either decide you might want to get the book, or Ben Lynch's book is another great book as a starting point, Dirty Genes, or this might just be enough for you. So as an introduction, there were some key milestones that have set us up for this nutrigenomics era that we're in. So Rosalind Franklin was using X-ray diffraction to produce the first images of DNA back in 1952. Then in 51 to 53, James D. Watson and Francis Crick published the first scientific paper on the double helix structure of DNA. And then 1961, Marshall Nirenberg cracked the genetic code. In 1986, we had the first identification of a mitochondrial DNA within human disease. And in 1990, the BRCA1 gene was discovered. 2003, we had commencement of the Human Genome Project, which announced that the complete sequence covered 99% of the genome. 40,000 genes are known to exist, but the function of half of those is only what's known to the human. So in 2005, we had the first genome-wide association study, or GWAS, and that was conducted only on 96 patients with age-related macular degeneration and 50 healthy controls. So, you know, not a massive study, but some of these studies are not that big. But the genome-wide studies are the studies that people seem to go to when they're starting to do testing and starting to deliver testing to the general public. So in 2006, 23andMe was launched in California. This is owned and managed by Anne Wojcicki, who's the wife of the Google entrepreneur Sergey Brin. And this was one of the first genetic testing companies that brought direct-to-consumer genetic testing. There are advantages and disadvantages to consumer direct testing. And there are some concerns. Now, 23andMe, the reason I think it all came into the UK very quickly in 2011 was the FDA pulled themselves down on 23andMe. It wasn't that they were doing anything wrong with their testing per se. It was simply that they were giving health advice to people direct to the consumer. Some of that health advice was talking about their health risks, such as dementia or cancers or things like that. And to be honest, when you look at the type of test, when you look at 23andMe, there is a certain type of person or certain types of people who would ask for genetic testing. And so you're not getting a cross-section of the entire population, which means you cannot predict those health risks from the groups of people that are likely to go for genomic testing. So you're not getting a full range of people. So that's one of the concerns. Another concern of the time was that people didn't know if their data was being shared, and that was a concern for some people. 23andMe is now being sold out to GlaxoSmithKline because they're going to use it for cancer, finding out which cancer therapies would be appropriate for which people. So all of that seems to have gone by the wayside, and I don't think many people are using 23andMe now. And we have a lot more testing companies that are more localized to us all, so that's not happening. The pluses are it can really help with trans-collaborative working possibilities, particularly across, for us, the NHS. It's probably easier for you guys in the US to do collaborative working anyway, but we have a real big problem with trying to work within the NHS because, of course, it's public funded. So people don't pay for health insurance per se. So, for us, it helps that in some ways. I've given a glossary of basic genomic terms in the book, and I've gone through how to read a genetic report, and there's a pictorial representation of that. I've talked about penetrance, and what I mean by that is single gene disorders where a mutation in a gene is said to cause a disease, and examples of this are things like cystic fibrosis or sickle cell anemia. So in 100% penetrance, this means every person who has the gene mutation will get the disease. Whereas what we're doing with the single nucleotide polymorphisms and nutrigenomics, we're not looking at set genes, we're looking at how the environment interacts with the gene and how we as complementary therapists can infiltrate with that and change expression. So throughout the book we've got a case study, and I've called her Ella. She's a very complex case, like most of mine. She presents with a diagnosis of gastroparesis, which is a non-functioning gut. She has neurotransmitter dysregulation, predominantly very low dopamine, very low serotonin, very low GABA, high glutamate. She's got a history of chronic fatigue, which is diagnosed. We have a lot of chronic fatigue that's not diagnosed here as well. She's got a history of trauma. She's got hormone dysregulation, dysbiosis. She's a type A personality, so she's driven, absolutely driven, and she's got a diagnosis of pyroluria, which we tested for, and that's quite crucial to her case, really. So within the chapter format, each chapter has an introduction. It talks about the individual pathway and how that functions, and with that there's a diagram to explain it pictorially. It then goes through all the genes and the alleles and the functions of those genes and enzymes in terms of their inducers, inhibitors and substrates, which we'll talk about in a minute. And then at the end of that section there are practitioner notes, which basically are telling you the key things to look out for, which are the genes or enzymes that could be problematic. Then I've put in Ella's SNPs in a diagram with an explanation so that we can compare to the original pathway. And then I've added the nutritional and lifestyle plan that we've done for Ella. So kind of thing you might see in the practitioner notes as an example, where let's say a practitioner is concerned about the enzyme CYP1A1. If there's evidence for estrogen dominance and that exists on testing and within the medical history, you might want to consider caffeine intake, estrogen mimicking foods and chemicals, genetically modified foods, and foods such as grains that are sprayed with glyphosate. You might also want to consider xenoestrogens such as coffee, black tea, chocolate, soy, dairy, non-organic meat and poultry, dyed apricots, dates, prunes, sesame seeds, chickpeas, beans, tempeh, alfalfa sprouts, bran, phthalates, and certain additives, shellfish additives particularly. So that's the kind of information you would get in the practitioner notes. The first section we've looked at, because we work from a functional medicine perspective, so we look at assimilation first, because as we all know, everything begins in the gut. So the first thing we've looked at here is FUT2 genes, fucosyltransferase genes, and the impact that they have when they're expressing on the microbiome, on B12 uptake, on secretor status, because these genes have been known for a long time. Peter D'Adamo identified these genes. I can't even remember what date it was, to be honest, but it was when I was training. He was really big on secretor status. And what he's saying is there are 3 particular FUT2 genes, and if they're homozygous, the person is a non-secretor, and that's a non-secretor of ABO antibodies into their mucus linings, so that leaves them more susceptible to dysbiosis. Also, with the FUT2, people seem, the new thing on the block at the moment is talking about the fact that these people don't have enough human milk oligosaccharides either. And there's a few studies here that have looked at that aspect. Now, human milk oligosaccharides are said to reach the colon where they act as a prebiotic. They balance the early microbiome. They're thought to protect humans against non-insulin dependent diabetes mellitus, and that's due to the beneficial effects within the microbiota. They generate short-chain fatty acids, and they have an action on T cells. There are currently some long-term studies being performed on the general population by a company called Glycom, who are a Danish company. And what they're looking at is whether we can add these to formula milk to give their babies who are formula fed a better start in life. So there's quite a lot going on with these human milk oligosaccharides. The other section we've looked at within assimilation is an intolerance section. And here I've looked at HLA genes, I've looked at histamine assimilation and function, cell membrane integrity and cell danger response according to NAVO. And the reason I've put cell membrane integrity here is because we obviously make phosphatidylcholine within the methionine cycle, and phosphatidylcholine is very influential for cell membrane integrity, and histamine breaks that down. So if we have a particular situation where we have poor methylation or low methylation, and we've got a mold or a histamine problem, then cell membrane integrity becomes a major problem, and that's what happened to me 3 years ago. So this is why this has really sparked my interest. The other thing I've looked at is alcohol and aldehydes, because obviously they are going to impair cell membrane integrity, and the body's got to break those down, and it's the same histamine pathway. I've looked at autophagy genes associated with things like Crohn's disease and dementia. So that's all in the intolerance section. And then at the end of assimilation, so this is just one chapter, I've looked at which test would you consider for this section, because I'm of the mind that we have to do this safely. If you're going to do genetic testing, you have to support that with functional tests, because we need to know what the expression is of each enzyme or each gene. And I think without that, we don't practice safely. And again, I'll give you some little tidbits later to say how we can see that. So I've looked at tests to consider for this section. I've also looked at possible approaches in terms of nutrition and lifestyle. Then I've brought in Ella's single nucleotide polymorphisms again. I've brought in her organic acid results, because the organic acid, which we use Great Plains over here, that's probably one of the most useful tests to run alongside genetic testing. It gives you the biggest number of metabolic end markers for the least amount of money. And over here, you know, they're very, very astute with their pennies, shall we say. I've then put in a plan for Ella to address her imbalances. And then behind that, I've put some practitioner key points. So I've talked all the way through Ella's case, what we did, what her genes were, and compared them to what the evidence says. And then where I've not been able to demonstrate something within her case that needs to be demonstrated, I've just done some specifics that says, you know, if not that, then this. So you've got like a plan to follow. So that's how each chapter is set out. I've got different chapters and sub-chapters. So at the end of assimilation, I've then got a whole section on histamine and mast cell activation disorder, because that's another one of my babies. I've got a section on biotransformation and elimination, and within that I've looked at hormone regulation, things like hemochromatosis, bile flow. I've also looked at pyroluria in there, because obviously pyroluria is a heme processing disorder. In the methylation cycle, as I said, I've looked at cell membrane integrity, folate, methionine, transsulfuration and biopterin cycles. Then there's a section on nutrient metabolism. So these are the tests that the gym bunnies, without being disrespectful, might like. The ones that tell them how many carbohydrates to eat and that kind of thing. Then we've got a section on neurodegenerative disease. So I've looked quite a lot about ApoE and how that applies, which forms of ApoE apply to which forms of Alzheimer's or dementia. And then we've got a section on inflammation, because as we all know, inflammation is the driver of disease. So that's kind of that's the genetic side in a nutshell. The other thing I've done is, because I'm very mind, body, spirit, and because I don't believe there's only one way to skin a cat, and I do believe I'm very Klinghardt led. I love Klinghardt's 5 levels of healing. And I do believe that we have to address all 5 levels of healing to be able to get full resolution of whatever our ailments are. I also love Epstein's 12 stages of healing and his reorganizational healing model. That was one of the things that really got me back on track. And it's just a beautiful model, and it's a really nice therapy where you hand your care to someone else, which I always think is nice. And what they do is very, very gentle manipulation, not even more than Reiki, to be fair. It's just spinal work, and you can look at this PubMed article, which is Epstein's, or you can go on YouTube and just Google Donny Epstein and see what he does, because it's easier to watch him on YouTube, to be honest. But I'll talk a little bit about it. So yeah, and by working with the spine, they get the spine to free itself from stress, or free the nervous system from the spine, because we hold it really tight under stress. And then the spine has its own natural network waves, so it literally waves like the ocean. And you can see that when you see someone having therapy, and when that happens, all the organs go into suspension where they're supposed to be. Everything loosens up. If there's trauma in the energy layers of the body, then that's released really gently, and there might be tears or they might be shouting, but you know, everybody just accepts that a box of tissues is not a medical emergency. So it's a really lovely type of therapy that doesn't mean you have to go and ruminate in all your history, because most people don't really want to do that. The last thing in the book is nutrigenomic competencies. So I've done a full set of competencies based on my experience teaching wise that I think people should have when they're doing this work. So this is just an overview of Klinghart's 5 levels of healing, which to be honest, I'll let you go away and read for yourself, because you've got the reference there, because I really want to show you the pathways. And Epstein's elements of reorganizational healing. This is just a 3-pronged approach, and it works on the premise that we have three areas: transform, discover, transform, and awaken. So in discover, we're working out what the heck went on in that particular scenario. And that's the bit about it's he said, she said, it was her fault, his fault, or whatever, or my fault, whatever. And then what you do is you kind of ruminate in that for a while, as we all know. You get into your story, and then you get insight. By having the treatment, you start to get deeper insight, because you're uncoupling the energy layers, and you transform that into something that you could use to go forward. And then awaken is when you become really enlightened. Now, this is not a linear model, and you don't go from discover to transform to awaken. We're always in the season of discover, because we're always trying to work things out, because we're human, and that's what makes us human. But we can go from awaken to discover, and we can do it with breathing techniques, or they can do it with breathing techniques, because in addition to this, they do something called somatorespiratory integration. And I've just put this website here because this lady does this stuff online. She's probably the only person in the UK who does it online. And then the Amazon link is to Donny Epstein's book. So, you can go and have a look for yourself. So that's kind of the preliminary. So if we go into reading the pathways now, and before we do that, I'm going to suggest, for those who haven't read it, to have a look at Dr. Ben Lynch's book, Dirty Genes. It's been out for a while now, and I think most people have got a little bit of a knowledge about it. He just picks up the 5 key genes that he thinks are really important, and he goes through the whole cleansing process, which is why he's calling it Dirty Genes. I love what he's done in that book, but it's a prelim to my book, to be honest. You don't want to be in mine until you've done all the basics, because I haven't covered a lot of the basics in my book. I've just said do this, but to get more information and to be able to do it off rote, you need his book. So what he's saying is you need to clean the genes first, because all of these causes on the left hand side here will set us up for gene expression, because what happens is they dirty the genes, and it's a bit like all your cat fur that gets into the corner of your kitchen floor. Once we have dirt on the genes, as it were, the gene expression starts to become altered. A classic one is dysbiosis, because we've got toxins from dysbiosis, toxins from heavy metals, all of that kind of stuff. Once you've got altered gene expression, you then start to get the symptoms, and if you ignore the symptoms, you then get development of disease. The symptoms, really, when you look at this from a mind, body, spirit perspective, the symptoms are messages to tell us to pay attention. Usually it's because we are ignoring our own emotions, because in Chinese medicine, the emotions are associated with particular organs of the body. And there's a few books on this out there, but I like Inna Siegel's quite a lot. She talks about the secret language of the body. So when I'm talking to my patients and they have specific things going on, I'll often give them an excerpt from that book, just to get them to see that actually there's some emotional connotations here. And unless they address the emotions as well, then they're probably not going to get 100% healing. And, but a person has to be ready for that. It's not for everybody. So that's kind of the nuts and bolts of the dirty genes. And when the genes are clean, as you can see here, you get healthy gene expression. And cleanliness is emotional as well. You know, if you've got a lot of like low, what do we call them, low vibrational emotions like judgment, and what's another one? Judgment's a big one. So, you know, when we've got that kind of stuff going on, we've got to work on with all of it. I think it's Bruce Lipton, who is the biology of belief guy, and Candice Pert, who has a book, Molecules of Emotion. They're both saying that we can change gene expression by the thoughts in our head. Joe Dispenza says the same. So it's all coming out now. That's not to say we don't have a valuable role, because we do. Obviously, we're the foundational work. So to start us off with the pathways, probably the easiest way to get to grips with these pathways is to go onto Google Commons and to just download Pathway Planner version 2, because it's free. You can buy a more updated Pathway Planner. You can buy up to, I think it's version 7 now, but it's much more complicated than this. And if you're a newcomer to nutrigenomics, you really don't want something that's highly you don't want anything that's highly complicated that you can't get your head around. So basically what we've got here is, this is Ben Lynch's Pathway Planner. I'm going to break all these down for you, because we've got four cycles here. We've got the folate cycle, we've got the methionine cycle, we've got the transsulfuration cycle, and we've got biopterin cycle, which is your neurotransmitters. So 4 key cycles, they all work like cogs in a wheel. So, you know, as one's going one way, one's going the other way, and they all support each other. And where we've got gene expression in some areas, we'll get compensation in others, because this is all one big homeostatic mechanism. There are codes on that pathway planner. So anything in orange, and I'll show you in a bit more depth in a minute. Anything in orange is a product that would increase activity of that particular enzyme. We call it a substrate, and we'll see some examples in a minute. Anything in purple would decrease the activity of the enzyme. So that might be a heavy metal, or it might be a toxin of some description. Anything in green is a cofactor, so that might be an amino acid or a vitamin or mineral. The reds are reactive oxygen species, which are obviously going to impair cell membranes. And of course, we've got a few areas in the body that are particularly prone to reactive oxygen species. And then the oval ones, they're not blue actually, they're white, but I couldn't put white on a white background. They're the genes themselves. So that's how to kind of read the pathway itself. So if we just come to the first gene that we've got on the slides, this is methionine synthase, or MTR gene. And one of its role is to convert a homocysteine to methionine, and it does it round the long route of the methionine cycle. So as you can see here, we were talking about substrates and inducers. So what have we got here? All these products here would decrease the activity of MTR. So what have we got there? Nitric oxide, lead, mercury, hydrogen peroxide, acetaldehyde, which is usually got lead, nitrous oxide, a high S-adenosyl methionine level, and TNF alpha. So all of those would block that gene working. You would get reactive oxygen species if you had a low S-adenosyl methionine as well. So you've got to balance it here. Now, in the UK, we can't give SAM as a supplement. It's banned. I know you can in the US, so you're okay with that side of it. Here we've got the cofactors. So for this particular enzyme, it's zinc, 5-methylene tetrahydrofolate, and methylcobalamin. So B12, folate, and zinc all help this enzyme to work. So that's kind of how the whole thing how to read it. Where does this sit within the methionine cycle? So it's sitting here. Folate cycle is down this side, which we'll see in a minute. And you can see here methylene tetrahydrofolate comes and meets B12 at the MTR gene, and then you pick up methionine from your food. That becomes methyl homocysteine, goes across to MAT1, and then into the transsulfuration system where we make cell membranes up here. That's not all on this pathway, obviously, but that's kind of what we need. So and one of the key genes is the PEMT gene, which we'll talk about further on. There could be other genes associated with all of this as well, because as I said, it's not one gene, it's not one pathway, the whole thing works together. So this is methionine. Methionine then is converted to homocysteine, which can then either go back up the quick route through BHMT. This is an interesting one because it's very zinc dependent. Look at all the zinc we need here. And pyroluria is B6 and zinc deficiency, which is why it's really important to Ella's particular case. So homocysteine can then get converted back to methionine through the long route or back up through the short route. BHMT is also interesting for people who, people are homozygous for BHMT, they usually internalize their stress as well. So if they're already anxious, they're the ones that ruminate, and we can't stop them going into their story. Or the other way homocysteine comes down is through the CBS gene enzyme into transsulfuration. So that's how to read that pathway. Now, as I said, we've got the folate pathway. They're now going to come together. So here's how we metabolize folate. And again, all the way through, we've got all these factors that might stop the gene working, factors that make the cell work, or the substrates that it needs to work, the cofactors in green. So they're all here all the way down. So what are we doing here? We've got folate receptors here. This SLC folate receptor is specific for synthetic folic acid, and the other two are specific for green leafy vegetable folate. And what happens is they all come down this pathway. We all know about MTHFR down here, but not many people think about all these enzymes here. So all these need to be working before you even get to MTHFR. So throwing in 5-methylfolate when you haven't got the pathway working might mean you miss out some of these vital steps, making your purines, adenosine and guanosine, and here recycling 5 to 10 methylene tetrahydrofolate. So you don't want to miss these steps just by putting in methylfolate. We need to make those steps work and get this pathway functioning better. So this is what they look like both together, folate and methionine. So we've got folate being converted down here from your folic acid or your green leafy vegetables, preferably green leafy vegetables and not folic acid. Then it comes and meets your MTR here, which is going to pick up methionine, go straight into the methyltransferase system, create your SAM, and create your phosphatidylcholine. And then it's going to come back down here to homocysteine, and then either short route, long route back to methionine, or down through the CBS enzyme. So that's a really easy way to read this. Obviously, you go into the individual genes if they are there. The other thing to look at is folate. If I just go back there, so folate also is going to come off here at the DHF enzyme. It's going to come off there, and it's going to go into this system here, because this is where we create biopterin, and where we create dopamine and serotonin, and we break them all down. Loads of things can happen in this pathway. It's a really interesting one. This one is the chronic fatigue pathway. as I said, it's the creation and breakdown of dopamine, norepinephrine, epinephrine, so it's all adrenals as well. And then down here we've got serotonin, so mood and sleep. And these all have to work. And we very often, in certain conditions such as autism spectrum, schizophrenia, we often get a blockage of this enzyme, primarily because these cofactors are not there, but also this can be very susceptible to heavy metal toxicity, and it's very susceptible to Clostridia overgrowth. And so what we can get is trapping of dopamine, which can look like there is no dopamine because VMA will be low, HVA will be low on your organic acids, and it looks like the person's not making dopamine. But when you look at their symptoms, you might see suicide ideology or anger, all of that kind of stuff. And that's when you know that this enzyme needs some attention. And of course, if you've got your gene results, you'll probably find this homozygous, so at least you know you've got to work on that. It's a really lovely pathway to work with this because you get some really good results really quickly. But it's one of those pathways where if you have a DBH enzyme and you give someone folate and they're trapping dopamine, then you can send them into suicide ideology very quickly. And I've seen this happen with a young lady who had an autism spectrum disorder and a really bad case of body dysmorphia. And her consultants, 4 of them, decided with her that it would be a good idea to do a sex change for her. So as to set her up for that, she was given testosterone. And as soon as her testosterone levels came above 11, she then went into suicide ideology, and she drew the most beautiful spider diagrams of it all when she came into clinic. So that was a really lovely case where we were able to work with our consultants and say, do you know what, we've got to, yes, you can do this, but you've got to be aware of this gene and this is what's happening. And it turned out to be a really lovely case and it all went through successfully. But in the early days, she came to me because she was on tube feeds, and this suicide ideology was coming and nobody knew why until we did her genes. So fascinating what it can do. The other section I want to talk about is transsulfuration. For anybody who's interested in transsulfuration, Stephanie Seneff is probably the world leader talking about this, and she's saying about 40% of us in the general population cannot sulfate. And we need to sulfate every hormone, every neurotransmitter, the cholecystokinin feedback loop of digestion, cell membranes, all your metabolic toxins, and anything that's coming in from extraneous toxins like your glyphosate or your hormone disrupting chemicals. And if you can't do that, then you go into rapid decline, or the body goes into rapid decline. We also need to sulfate vitamin D. Is if we don't sulfate it, then it's not going to, whilst we might increase active blood levels, it will not go into the system and make the T cells do what they're supposed to do and support the immune system. All we get is a high level, and we see that quite a lot. So transsulfuration, what it's doing is it's taking homocysteine down to glutathione. There's often GSTM SNPs completely missing. So when that occurs, glutathione can be low, and again you can see your glutathione levels on your organic acid test, so you can see how well this pathway is working. Again, B6 and zinc here, so pyroluria, people with pyroluria generally can't sulfate. There's also often a problem with the SUOX enzyme. We used to say the SUOX gene, but I see more and more people every day where the SUOX gene looks fine, but it's obvious the SUOX enzyme is not working. So we can get that kind of scenario as well. So the genes are not going to often give you everything you need. You still need to look at your symptoms. You still need to look at your functional tests. Because specifically with SUOX, I see it so much. And really, it only needs a little bit of molybdenum and B2, to help the person convert the sulfur to the sulfite to sulfate, which is what needs to happen at the end of this methylation cycle to sulfate all your hormones, neurotransmitters, etc. So for me, this is one of the most crucial, it's one of the most crucial aspects of the whole system, to be fair. It malfunctions in more people than I know. You sulfate really well in the sunshine, but of course over here in the UK we don't really get any. We've probably had our best summer ever, and that's probably because we haven't had aeroplanes flying because of COVID, and not much traffic either. The other place you can sulfate is by being in salt water, so swimming in the sea, walking on the water's edge, which is probably why we all feel better when we do that. You know, for us in the UK, we notice it more because we don't have the weather that you have in your summers. And when we go to the seaside, we actually feel the benefit because we will walk in the water's edge, however cold it is, most of us, and we notice that. So how's the other way you can sulfate? Epsom salts baths are a real bonus. We just have to be careful that when we start someone off on an Epsom salt bath, often we have to start with a really low dose. I mean, the general rule from the research of Stephanie Seneff and actually NIGH has a beautiful paper on the NDNR website, and he calls it SIBO as an adaptive mechanism. And what Nye is saying is that he thinks we have a massive amount of SIBO in our population because we're not sulfating. And so one of the first things he does is he gets people in an Epsom salts bath, which I do that more than anything. So it's Epsom salts baths, it's B2 and molybdenum for the SUOX enzyme, and then it's usually a pyroluria supplement because they usually have pyroluria as well. Not everybody, but the vast majority. So that's the transsulfuration. Some key takeaways that I would just like to give you are: the genes are not our destiny. I hope I've demonstrated to you in a small way that even though the genes look okay, the enzymes can be not working, and vice versa. Methylation is homeostatic. We have a real duty of care here because we can, because of our need to heal the world, and a lot of us who are healers have that inbuilt need to do that within themselves. But if we lurch in with B12 and folate and we try and wind up methylation from the central core before we've done the neurotransmission, before we've supported transsulfuration, we can get ourselves into a sticky mess. We can get ourselves into a mess with the dopamine pathway that I've just mentioned. But we can also get into a mess because when the body is sick and it's making sick cells, i.e. in cancer, let's say, just as an example, there are other diseases as well, but cancer's a big one because it's close to all our hearts. When we've got a situation like cancer growing, and the methylation is slowing down, it's probably slowing down because it doesn't want the body to make more sick cells. So if we go rushing in with a load of B12 folate and winding up that methylation without detoxifying the person, without balancing all the other cogs in the wheel, then we could be in danger of exacerbating the cancer. And there's loads of research on I think it was Canadian studies where they looked at where they fortified grains with folate, and they had a massive increase in colon cancer. And that's just one example. I think it was the EPIC study, if I think back to my digestive days. So you'll find loads of that in Google. As I said, each individual cycle is a cog in the wheel, so they all need to be respected for what they bring to the table. The genes instruct enzyme function. They tell a protein what to do. They instruct the protein. The protein is an enzyme. The enzyme creates a catalytic conversion. I think we always have to run functional testing along genomics. I always start with an organic acid because, as I said, it's the cheapest one with a maximum number of markers to start us off. Sometimes I use a methylation profile as well if I need to know SAM-SOR and homocysteine. That might be the other one I might add, and I'm probably more likely to do that in a cardiovascular case than I would in anything else, because I don't often run that test because it's quite difficult to get it here because it has to be centrifuged. You might do gut tests as well, and you might do SIBO tests or whatever seems appropriate for that person. And I think my final message to you would be, before you start throwing in amino acids, vitamins, minerals to get the genes working or to support the gene function, clean up the environment first. As Patrick Holford would say, the genes set the scene and the environment pulls the trigger, and we can be more responsible for the environment than we can for our genes right now. So that would be what I would give you as a takeaway. So I hope that's been really useful to you. I want to say thank you for your attendance, and if you've got any questions, I'm happy to take them now.
Thank you, Anne. That was absolutely fantastic. Lots of great tools and resources there. Would we be able to share the slide deck? You've got some great links in there, or perhaps you can send me the links, yeah?
Yeah,
okay.
Absolutely. I'll send you the slides over. Yeah.
Fantastic. That would be really great. And can you recommend any lab companies? I know that we've got some people in the UK, some people in the US, but are there any particular companies that you could recommend?
Personally, in the UK, I just use BioLab.
Okay.
And the reason I use them is because I like Mark, to be honest. He's very authentic. He's very helpful. He runs all the Great Plains laboratory tests, and some of them are the best ones in the world, aren't they? We all know that. I also like it because he doesn't add a massive amount of cost to the patient. So he sells them to the practitioner at whatever, he doesn't sell them to patients at all. But if he was selling them to patients, they would go to both at the same price. So he's not hiking prices up, which means it's up to you what you charge. But at the end of the day, he's charging 185-ish for organic acids, and some of the others are charging well in the 200s. And you know, this is all expensive for our patients. They're paying us. They're paying for the gene test, and they're paying for the organic acid. So by the time they've seen me, it's nearly cost them £1,000 already. So I kind of think I ought to help them with that.
No, that's great. So BioLab for the UK, and maybe offline you and I can perhaps talk about potentially some that for the US people. You mentioned the organic acid test, and for anyone listening, next month I actually have Kurt Waller who will be presenting the organic oat test, because I agree it is a fantastic test, and so it's a really nice kind of follow on because it will, you know, carry on from where we are here today. So Jennifer is saying she's in awe. Thank you so much, Anne. I think we can all agree this has been a really great and comprehensive presentation. So in terms of reaching out to you, Anne, is it okay if I share a link to your website, etc., and can people contact you, learn more about your book?
Lovely. I'd love that, Andrea. Thank you.
Okay. All right. Well, for everybody listening, thank you for your attention today. So as mentioned, next month, the presentation will be Kurt Waller, and he will be presenting the organic oat test. So please mark your calendars. And I can't believe I'm saying this, Thursday, January the 14th, sorry, I apologize, the 14th of January. So thank you for everyone who's attended today. As mentioned, you can earn 1 continuing education credit by attending the quiz and of course passing the quiz. The recording will go out tomorrow with links mentioned here today, the slide presentation, and of course any further information and contact information for Anne. All right, everybody, thank you for joining us today and enjoy the rest of your day. Bye for now.